So I think it's important to maybe to address first the focus on the losses, the drip loss, the cooking loss. And I would like to ask our scientific experts today to explain what is behind, in fact, drip loss and water holding capacity. So I say the first question could be the link between drip loss and water holding capacity. What is the change a muscle is facing going from muscle to meat? And what is the importance of the cell membrane integrity? And I think I could ask Massimiliano to explain a little bit more what is the transformation and what is the drip loss at the muscle level.
Okay, I think that first of all we need to say that meat is composed by 75% of water. So water holding capacity is very important technological property because it's the ability to retain its own water. And this property change a lot during postmortem time because at the beginning water, just after the death of the animal, is contained inside of muscle fiber. But during transformation of muscle to meat, we have formation of extracellular spaces and there is contraction of the muscle due to rigor mortis development, and there is a squeeze out of water from the inside the cell to the outside of the cell. And water that are present in the extracellular spaces can be lost during storage or processing, especially if meat is cut. If meat is cut, there is a huge loss of water. And the drip loss is associated especially with postmortem acidification rate, ultimate pH, and membrane integrity, as we will see later. For cooking losses, this situation is a little bit different because, of course, following cooking, there is a very huge loss of liquid, not only water, but also protein and fat. And there is two key points during cooking treatment. First of all, around 40 to 50 Celsius degree, we have a longitudinal shrinkage of the muscle, and these promote, of course, loss of water. But we have another key point during cooking treatment because around 70 degrees Celsius we have a transversal shrinkage of the muscle and then a huge flow of the water from the muscle to the external spaces. And if drip loss is very associated to ultimate pH, for cooking losses are also important the protein content of the meat and especially the quality of the protein. Because, for example, collagen is not able to retain water. So, if meat is very rich in collagen, poor, especially very poor meat cut, both in poultry, pork and beef, we have huge loss of water. And so we have, of course, protein denaturation following cooking, but at industrial level, for manufacturing processed product, we have also addition of salt and ingredient. And salt and ingredient can help to bind water, its own water, but also water that are added during processing. And especially for drip losses is very important membrane integrity. Membrane integrity because, as explained before, water is entrapped, the majority of the water is entrapped inside the muscle fiber. So if it's possible to maintain as much as possible membrane integral, so in this way you can keep water inside the muscle fiber. But if there is loss of membrane integrity, there is also loss of water from inside to outside spaces. And to protect membrane integrity, for example, it's good to add vitamin E in the diet because vitamin E is able to protect phospholipids that are in the cell membrane and in this way to protect membrane integrity. And if we need to resume the factor that affect water holding capacity, we can say that overall it's very important the protein content of the meat and also the quality, especially related to the collagen percentage. Also are very important the protein charges, as we will explain later. Protein charges depend on the ultimate pH of the meat. Protein denaturation that can happen during cooking, but can happen also during transformation of mussel to meat. So we will say that if pH is low and temperature of the mussel is very high, we will have a protein denaturation also in fresh meat. Cell membrane integrity, as explained, and only in further processed product, addition of salt and ingredient added during formulation. And water holding capacity is very important property because affects several properties of the meat. If you use meat as a raw material for further processing, water holding capacity affects processing yield, so there is a very implication on economical issue. Water holding capacity affects sensory property of the meat because if there is a huge loss of water during cooking, of course, meat is lost juiciness and can be also less tender. Nutritional value because, as I said before, there is not only loss of water, but within water there is also protein and fat, also in fresh meat. Shelf life because liquid inside the packages can affect appearance of the product, but also can promote microbial growth. And so water holding capacity is a very important property of the meat.
It's interesting what you said, Massimiliano, because you stress a lot on the protein aspect, so the protein quality. So I think we will see later on with Cécile about maybe the interaction on the amino acid supply and the meat quality. But I would like now maybe to ask another question, because we started to talk about ultimate pH. So what is the relationship between ultimate pH, water holding capacity, and drip loss? And maybe Cécile, I know that you are using very often this slide, but I think it's very important to explain to everybody what are the interconnection between these issues.
Okay, so as Massimiliano mentioned, the post-mortem pH fall that occurs after death in the muscle is very, very important. Maybe is the key parameters that determine water holding capacity in the meat. I mean drip loss, cooking loss, and even processing yield. So there is two traits during post-mortem pH fall. The first main character is the initial rate of post-mortem pH fall. That is measured usually at 15 to 20 minutes post-mortem. And it is in broiler and turkey much related to the activity of the birds on the slaughter at the slaughter plant. For example, when there is a lot of wing flapping, the initial pH fall will be very fast. And in this case, the meat produced will be called PSC meat, for pale, soft, and exudative. And as you can see on the slide, this meat is very light in color, very exudative, and it will have also a very poor processing yield. The other condition is related to the ultimate pH of the meat. And in this case, the activity of the birds is not very important, but the main parameter which determines the ultimate pH of the meat is the amount of glycogen stored in muscle at death. If this amount of glycogen is low, the meat produced will have very high pH, and it will be called the DFD meat, for dark, firm, dry meat. And this meat, as you can see, is very dark in color. It is very dry in the marrows because the water is very well conserved, and so it's not very good when you taste it. And a problem can be also the poor storage ability of this meat because of the high microbial evolution during storage. On the other side, there is the acid meat that is produced from muscle with high amount of glycogen. And for example, in the case of the breast of broiler, acid meat is considered as acid when the pH is below 5.7. And in this case, as the PSC meat, the meat will be very pale, exudative, and also will have a very poor processing yield.
So in broiler, we talk more about acid meat and I would say DFD meat than PSC meat compared to pork.
Actually, the PSC meat does not concern so much the broiler, but may concern more the turkey because of wing flapping, but also the fact that after slaughter, during processing of the carcass, the temperature remains high for a long time because of the weight of the animals. And there is a condition with a high temperature, a low pH, and in this condition, the protein of the muscle are denaturated. And in the case of broiler, this condition, because of the low weight of the broiler, is not the same because of the chilling procedure that decrease the temperature quite quickly.
So you mentioned turkeys. Do you mean that, for instance, heavy broilers would face the same issue than, I would say, big birds like turkeys, or it's totally different turkey and broiler?
I'm not sure there is any information about that, but for big broilers, I think processors, they have to manage well the chilling and cooling procedure of the carcass to avoid this happens.
Okay, so regarding the ultimate pH, can you precise a little bit more? What does that mean really regarding the protein structure and so on?
As I said before, pH, especially ultimate pH, affect the protein charges distribution. As told by Cécile, if pH reach very low value, like 5.7, 5.6, so we can classify this pH as associated with PSC condition. In this way, pH is very, very close to the isoelectrical point of the protein, which is the means of isoelectrical point. Isoelectrical point means that positive and negative charges present on the surface of the protein are more or less the same. At this point, the ability to retain water is minimal in the meat because the structure of the myofibrillar present on the muscle fiber is very sticky, and in that way there is very low spaces available for hold the water within myofibrillar spaces. And so this is why PSC meat has a very low ability to retain water. As opposite, if the pH remain on value higher than 6, 6.1, 6.2, pH is very far from the isoelectrical point, so there is a huge amount of negative charges, and these negative charges can bind water, and structure is more open because of the repulsory energy in the muscle. So in that way, ability to retain water is higher. And these PSC and DFD are problem that we can find especially in poultry, but also in pork meat, while in beef we can find especially DFD meat. So it seems that both poultry and pork are more prone to develop PSC condition. This may be because especially breast muscle and loin muscle for pigs are composed especially of white fiber, and white fiber are more rich in glycogen, so during postmortem time there is higher production of lactic acid, and in that way pH can drop around value very close to its isoelectrical point. So the measure of pH, for example, is a way to understand if to determine the waterability of the meat.
So, in fact, more than talking about PSC and DFD meat, we should say acid meat. And how do you qualify the DFD meat? I would say high pH meat, or but finally, it's more than PSC. It's acid meat in broilers. I would say in poultry. In pork, I understand that it's PSC meat, and they have the same issue regarding the dry, firm, and
I
dark
think
meat.
there was a confusion many years ago about PSC condition and acid condition, because really when you see a PSC or acid meat, for example, breast meat, broiler breast meat, they look the same and they have about the same traits. But most of time when we saw a meat with a light color and very exudative, it corresponds to acid meat, which means a meat with a low pHU. I would say maybe in Turkey it's a little bit different, because we know that in Turkey there is both condition, the PSC and the acid condition.
Maybe we can ask Paul again about what are the practical consequences of high drip loss, low water holding capacity for the poultry processor and for the slaughter plant. So maybe, Paul, if you can comment on that. What are the practical consequences?
For the poultry processor, we are facing two situations which are different from, are we on a tray retail pack, or are we on processing, further processing product? If we are in a tray retail pack, we can see in any country, in any tray, that there is more drip loss than there were many years ago. And now it is also very different. If you see on a tray, you don't need to look at the date or best before, because when you see the drip loss, you can say without any labeling how aged is the meat.
Paul, and do you think that the consumer at the end react quickly to those issues?
I'm not so sure, because you have it depends on the kind of tray you have. Is it vacuum bag? Is it skin pack? Is it you have a folder? So there are different way to absorb it or not. So, and it depends on if it's transparent or not. It depends on how the product is displayed and shown to the consumer in the tray. That is on the marketing retail side. About processing, what we are facing is we can see when we are selling meat in bulk, I would say 500 kilo bag, that there are more or additional, it's not water, of course, it's drip loss in the bag, but it depends after which kind of processing we are doing. If, for example, we are processing them to make a ham, and we are taking out the water before processing, of course, there is a loss of yield. But if we are processing them, that is to say, for example, to make nuggets, and we are processing at a very low temperature, not negative, at very low temperature, drip loss are binding with the meat, and there is no effect.